Thanks very much. Well, I'm from another rainy city. I'm from Brooklyn in New York, so miss the rain. Thanks for having me here. I'm joining a little bit late, so I don't have a full talk. It's not a technical talk. I'm going to do a demo of something that I've been working on for quite a while now. I work on a project called DXOS, and that stands for the Decentralized Operating System. And it incorporates a real-time graph database that synchronizes peer-to-peer. And it's used for building real-time collaborative applications. I've got just a few slides, don't worry, and then we're going to go into a demo. If anybody's got a tablet, that'd be a really big help. I've got one here as a backup, but it's usually better if there's somebody who can work with me to do that. Okay, so first thing, why do we care about local first? Why do we care about decentralization? As Sam said, the field has been evolving for the last 10 years or so. In fact, I worked for Google 20 years ago, 15 years ago, at the beginning of Google Docs. We made an acquisition in 2006. That was the beginning of Google Docs. And that was built on a technology called operational transformation that is a precursor to CRDTs. So this technology has been evolving and getting better and better. But we still have to ask, why is it important for us to be decentralized in the first place? And we think there's both principled and functional reasons for decentralization. And a lot of people talk about the principles of data sovereignty, owning your own data, being privacy, tolerant, being able to publish whatever you want without being censored, open source principles. And these are really important things, but it won't fundamentally change users' behavior unless there are functional benefits. And so what we've been trying to focus on is, what is the better user experience that we might get from having local first applications? Lower latency, working offline, maybe lower cost. What's the better, is there an opportunity for a better developer experience? Is it easier to build applications or more difficult? Currently, it's a lot more difficult to build offline first applications. So what is necessary to make it easy for us to build these kinds of applications? And if we can do that, what does the ecosystem look like if we can align the interests of the developers and the end users? So, this is what most of our desks look like right now. This isn't actually my desk, it's my metaphorical desk. I've got data everywhere, and I'm juggling dozens of different applications. And in principle, I can get my data out of my applications. But for the most part, the companies that are building software are trying to be the hub around which all of the other applications integrate. So there are some really good applications. I mean, we use Notion, we use Airtable. This great user interfaces is a great set of features, but the business model is built around capturing the end user. And the end user might be an individual, it might be an organization. And so while they might have APIs for extensibility, it's not part of their business model to let people have access to their own data. So we've been thinking about what kind of database would make it easy to build applications where you're no longer juggling different silos and different applications. And then, of course, AI is in everybody's minds, and everybody's trying to build this. And we're thinking, what kind of database would make sense so that you could train your own LLMs, your own artificial intelligence models, and have the model itself be aware of the activity that you're currently doing. So the cornerstone of DXOS is the Echo database. Echo stands for eventually consistent hierarchical objects. It's a fully peer-to-peer graph database. It doesn't require the cloud. It doesn't require servers unless you want to add them. There are reasons why you might layer in a hybrid server solution at some point. It provides real-time data synchronization, peer-to-peer, with pluggable CRDTs. So for the most part, developers they don't need to get involved in the intricacies of the CRDTs. They can just use the standard plugins that are part of the Echo data model. Structured and full text queries, strongly typed objects. So TypeScript bindings, for example, generated from protocol buffer definitions of strongly typed objects, but there's also a runtime schema. So you've got the metadata at runtime so you can introspect on the data model itself. really enjoyed Paul's talk about access control and security. We have, I think, a simplified version of access control. It's very challenging to do that in a distributed ecosystem. And perhaps one of the most ambitious or important characteristics of Echo is to realize an internet scale database. And we do that through federation. So you can have thousands of individual Echo database instances that are linked together to form a hypergraph. And I'll go ahead and show an application that's using that in a moment. And then finally, we have a system of agents. So you can build server-based applications or peer-based applications that you might run in a server that will be executed whenever there's a mutation on the database. So you can think of these as lambdas that are acting as if they were database triggers. Okay. So if I exit the presentation, I'm actually using an app that we've built on top of the platform. This is an app called Composer. And you can see I've got my slides organized here. What I'm going to do is create a new space. So bear with me a moment. Okay. So we organize the database into Echo databases that are called spaces. And a space is an object graph that any application running on the platform is able to access. So for example, I can create a new stack. And a stack is a kind of document. Second. All right, here's the first gremlin. Let me try reloading this. So I was working with a colleague earlier today, and we're building a little demo for today. And we may have introduced a regression here, but let me see what I can do. Show hidden spaces. Space. So this is the space that I was demoing from earlier. This is, let's try something else here. Okay, so something is working. Here's what I'm going to do. I'm going to show how to do collaboration. So the first thing I can do here is create an invitation to share this space. And I'm going to try to, does anybody have a tablet ready? See if this will work. I'm going to show you, are you able to scan that? And I'll do the same thing here and see if we can get it working that way. Okay. Who's the first in? You were doing that as well, Sam.
I was trying. Joining the space, apparently.
Are you in?
Connected.
Okay. And I will do one for myself here, and we'll see who gets in first. So, did you get in? Okay. All right, I'm in over here, so. Okay, we are connected. So what just happened is these two peers are connecting through WebRTC peer-to-peer. The QR code has the URL of a discovery key, and then the two, and somebody else is in as well. Is that James? Brilliant. Okay, thank you. We were able to swarm now, create a WebRTC connection by discovering each other through discovery keys that are being broadcast through a signaling network. And then the signaling server enables the WebRTC clients to do the UDP hole punch so that we are now connected peer-to-peer within the room. We could go off the internet. We could be disconnected from the main internet just on the local LAN here. What I'm going to do now is go back into the stack and create another diagram here. You can see this is TL draw. We've integrated TL draw and conformed that to the CRDTs used by Echo. So I can drag that sketch into the stack. No. Okay. All right. I'm going to try one last thing. Okay. Thank you for bearing with me here, guys. I'm going to switch to localhost. Do I have a few minutes? Okay. I'm going to create a new space here. And so part of the Composer application that we're building is, what part of the goal is to make a pluggable ecosystem where any developer can extend the basic functionality. So you've seen that we've got documents, we've got TL draw integrated, so we've got simple diagrams, we've got tables. So for example, I can create a simple table with multiple columns and rows. I can generate some test data here. No, it's not going well. Sorry, guys. Here's the last thing I'll try. So this is a chess game plugin developed by another developer. And what I'm going to do here is connect the agent. So if I start that running here and create an invitation. Okay. Now, okay. So what we have here is a peer that is a headless peer. It's running as a local server that's also connecting into the swarm, and it can respond to mutations in the Echo database. And it's not the greatest chess engine. As you can see, it's just making a random move. But I'll show you what the code looks like. It's very, very simple. So in order to build these little extensions, a remote function can be as simple as this. So you can see that we have a client instance, which gives us a connection to the swarm. That also has the identity of the user or the agent. And then we can query for typed objects within the space, create a subscription. And then whenever there's a mutation, our function gets woken up and we can, in this case, just guess the next move. Now I'll show you finally what we've been playing with today, which has caused the problems. So do you know how to play chess? Okay. So what we're experimenting with is this lightweight plugin model where you can build React components that can plug in and dynamically be loaded into the application at runtime and introspect the graph database. And also these Lambda functions that can similarly be plugged into the system and dynamically be invoked due to changes in the database. So can you suggest the next move? Here we've built a little function that talks to OpenAI, and it's looking at the state of the database, making a query. It understands that what the user is currently doing is playing chess. It's extracting the state of the chess game and feeding that in as part of the prompting state to the LLM. And is this a good move? Queen moves to h5. Not sure. And then to finish, I will show one last thing here. So there's other kinds of applications that we've built that might be a research tool. And so I could say, you know, what is YJS? And use this to query the LLM. But I can also have it interact with the current scope of what the user is doing. So in this context, I can say list 3 open source projects that use YJS output as a structured document. And here it's understood that I'm building a collage of information cards that I'm using to research, and so I can now drag this information directly into the application. And so you can imagine different kinds of integrations that we can do, where we can actually train the LLM on the content of the different spaces. And if you give the LLM access to your agent, then it will have access to all of the different spaces and be able to structure and research information for you. So thanks for bearing with me. A lot of last minute gremlins here, but I appreciate your patience. And we're hiring. We've just launched our preview of our SDK. Also looking to potentially sponsor people who are interested in building applications on top of the platform. If that's something you're interested in, please let me know. Thank you.
I think we might have time for 1 or 2 questions, and then we're going to break for 15 minutes. So does anyone have a question?
Hi.
Hello.
So I had two quick questions. Maybe the first one is not very quick, but because the goal is to decentralize the operating system. So I was curious if there's a way to decentralize the large language model as well, or is it a central point at the moment?
So the LLM isn't a core part of our technology. It's what we think of as a very interesting use case, and we're looking for people to collaborate with on that. I think what we're likely to see is a hybrid model where the LLM's main training set is not personalized. It's one of the standard sets, and so that can be trained offline and then run locally as part of the Echo agent, which would then be further trained on the data relating to the individual or the organization. And so in this hybrid model, we think that we can have LLMs that work offline.
Okay, thank you. And I wanted to ask if there is an open source GitHub project that we can look at and maybe contribute.
Yeah, absolutely. So the project is at DXOS.org, and GitHub DXOS has all of the code open source. Everything that we're doing is open source. It's a mono repo with about 300 sub repos inside of it that includes the database layer. We have networking technology, identity, decentralized identity, and a suite of applications that we're building to demonstrate. So if that's something you're interested in, we'd love to have you take a look at that and maybe give us feedback through our Discord channel. And you can find all of that on our website.
Question over here. Oh. If you click on the, you just read.
Does DXOS require the use of IPFS, or can it run good old connected web servers? So we do use IPFS. We use IPFS as a blob store. So the presentation slides that I was showing earlier. These are images that were uploaded onto IPFS. It could be WinFS as well. But all of the data, the real-time data, the database tables that I showed here, these are records that are stored in browser local storage on the local device, or in node file storage in the peer that's running as the separate server. So it's a hybrid model. And was that the last question? Oh, right. Yeah.
So thank you very much.
Okay.
And thank you for showing.
Thanks so much. Thank you. Thanks, everyone. Thank you.